This is part 3. So this is number 22. It wants me to take the rectangular coordinates and put them into polar coordinates. So I need r and I need theta. So if you want to pause the video and try this, you go right ahead. But I do Pythagorean theorem for this. So 3.7 squared plus 3.1 squared equals r squared. I take the square root and I can throw that in my calculator and that will give me r. And then to find theta, I can do tangent theta equals 3.1 over 3.7. So that means tangent inverse of 3.1 over 3.7 will give me that angle for theta. All right, number 24, ask me to multiply two vectors together and then divide two vectors. So really quickly on that, when I multiply two vectors together, I multiply the r's and I add the thetas. All right, so I'm going to add these two and add these two, which is the same. All right, so this is r, when I write this equation, r cosine theta plus I sine theta. It's been a while since we've done that too, but that's how I write that. So I'm going to multiply my r's together, so z times w is 9 times 9 multiplied by cosine pi over 5 plus pi over 10 plus I sine pi over 5 plus pi over 10. Now it becomes a cleanup activity, adding fractions, multiplying whole numbers. So 9 times 9 is 81. When I add these two fractions together, I find common denominators. So that ends up being 15 pi over 50, but I can divide that by divide that by 5. So 3 pi over 10, and I don't have to redo that for sign because it's the same numbers. So you can probably guess what you do with these when I divide. I'm going to divide my r's, so 9 divided by 9, and I'm going to subtract my angles. So now instead of when I do pi over 5 plus pi over 10, it's pi over 5 minus pi over 10. So that's going to be 5 pi over 50 when I subtract those, or when I reduce pi over 10. All right, so cosine of pi over 10 plus I sine pi over 10. And that's it. You don't have to do anything else. It asks you to put, actually, that's a lie. That's a 1. It asks you to put it in exponential form. Exponential form is pretty fast. So it's r e to the I theta, and you're just plugging in r and theta. So this one would be e to the I times pi over 10. This one would be 81 e to the I 3 pi over 10. And these are used in different ways to calculate, like just shortcuts to write formulas and be able to calculate faster. So it's kind of intro into vectors and polar form, and that's fine. 25, you're basically doing what you did in 24 when we multiplied vectors. It's just a shortcut. So if I had to write this out 6 times and then multiply, think about what you would do for that. I would multiply my r's, so square root of 5 times square root of 5 times square root of 5, 6 times. So the shortcut would be 6 times the square root of, I'd multiply the square root of 5 by itself. Square root of 5 times square root of 5 times square root of 5. So square root of 5 to the 6th power. And then I would add my angles. 7 pi over 24 plus 7 pi over 20. I would do that 6 times. So I can just multiply that. 7 pi, oh my goodness. Come on now. 7 pi over 24 plus I sine 6 times 7 pi over 24. So that way you don't have to write it out 6 times. You can if you want to, but you definitely don't have to. So I take 5 to the 6th power, square root of 5 to the 6th power, which means 5 to the 3rd if I want to get rid of the square roots. Totally can do that on your calculator. So 125, and then I can reduce this to a 4, cosine 4 pi plus I, that's a pi, plus I sine of 4 pi. And then if you don't have to calculate that, all right, you can just leave it. But if I wanted to put it like in rectangular, polar, I could calculate cosine of 4 pi and I could do all the things. Then to put it in exponential form, it's 125 e to the I times 4 pi, or you could put 4 pi times I, either way. Let me check my time and make sure this is recording. Okay, good. All right, number 26, ask me to create a position vector with a starting point and a stopping point. So right now, this vector starts at 3, 3 and goes to 10, 6, and they want me to move it back to 0, 0, basically is what they're doing. So I'm just translating it back. And to do that quickly, I do 10 minus 3, and that's 7. And then 6 minus 3, and that's 3. So this is called a component vector. We did these in Algebra 2, so my component vector is 7, 3. When they want me to write it as a position vector, this is A and this is B. So V equals 7I plus 3J, and that's it. So basically we've just moved it back. This is my new vector. A is 7, 3. The magnitude, so if they ask for the magnitude, that means the length of the vector. I could do 7 squared plus 3 squared and find the length. And that's it. That's all. All right, so 27 actually tells me the magnitude of this vector V is 28, and the angle of the vector that the vector makes with the x-axis is 300 degrees. So I went 300 degrees and that gave me 60, and then I went on the unit circle and found my side lengths. This is on the unit circle where R is 1, so I'm going to multiply everything by 28 because that's what they told me, that it was 28. So I'm going to multiply my x coordinate by 28 and my y coordinate by 28, and when I put this in this form, I know that A is 28 times 1/2, or half of 28, which is 14. And I know B is negative 14 times the square root of 3 when I reduce that. That's it. So use what you know about trig, draw your triangle, and then create your vector. Right? And then 28 is dot product, which we did not get to. Well, that's not true. Some of you guys that were in class we got to, but it was a day where everyone wasn't in there, and so if you've seen this, you can skip through the video. If you haven't, then here it is. Dot product does not mean multiply these two together. We already know how to multiply. Dot product does mean multiply the x's and multiply the y's together and then add them, so you end up with a single number when you do dot product. So I'm going to multiply my x coordinates together, so 8 times 1, plus multiplying my y components together, so 1 times negative 8, and then I'm going to add those, so that would be 0. 8 and negative 8 is 0. All right, so that's how you do dot product. All right, when they ask about the angle between vectors, that tells us, when I find the angle between the vectors, that tells us if they're orthogonal, which means perpendicular, or if they're parallel, or if they're neither. If I come up with 0 on the dot product, they're orthogonal, and I'll show you why. That's going to lead to a 90-degree angle. So the angle between vectors, so the angle between is cosine theta equals the dot product of the two vectors, and then you're going to divide by the length of both of the vectors. So here's the deal. We already did the dot product. We know it's 0. Really doesn't matter what the lengths are because this is going to be 0. Where is cosine 0? I want cosine inverse of 0. That happens at 90 degrees, or at pi over 2. So if I have the angle between two vectors is 90 degrees, they are perpendicular to each other. So in vector notation, or when we talk about vectors, that's called orthogonal. So the vectors are perpendicular to each other. They're parallel to each other. You'll end up with 1 on the top, and they'll be parallel. If you end up with something else, then they're neither. All right, that's it.